In the smart grid world, key considerations for utilities are stability, field-proven and interoperable devices across deployments. With the digitalization of the distribution networks, security has also become of high importance when considering both consumers, where data privacy becomes a fundamental issue, and the distribution network, where intrusion, data manipulation and tampering, data authentication and confidentiality are all to be considered. It could be said that security is one of the critical elements, but this is not just the case for the energy sector.
In any application where data are stored or exchanged, or whenever applications are controlled remotely, dedicated security mechanisms are of the essence. The Internet of Things is a good example. It allows objects to be sensed and to be controlled remotely across an existing network. Each object is uniquely identifiable, and it can interoperate with the existing Internet infrastructure. The protocols that are usually used are well-known open standard protocols, and it wouldn't take long for criminals with a dedicated technology knowledge to intrude any of those systems. It is not different for applications in the smart energy sector, which are equally vulnerable. Also here, it is all about data storage, data exchange, and remote control of the network. Prime is taking the adequate measures, ensuring the confidentiality, the authenticity, and the integrity of data.
Security is not new to utilities. As energy networks have evolved over many years, security has become a growing issue for the energy sector, with learnings made from experiences with SCADA systems, high and medium voltage networks, as well as billing applications. The importance continues to grow in the distribution network area.
We understand that the deployment of the smart meters in the network represents a cybersecurity risk because they are intelligent devices with communications allocated at the customer premises. Our priorities are to protect the electric service itself and to guarantee confidentiality and integrity of meters data. For that purpose, we implement security solutions based on the DLMS COSEM standard running on Prime. One of our main concerns is the impact on performance, speed and reliability, and we are quite satisfied with the results. The solution we have implemented is in continuous evolution, following the security requirements and the state-of-the-art of technology.
Massive smart meter rollouts based on Prime technology are taking place all over Europe. Utilities involved in these smart meter rollouts in the end realise that, further than a smart metering infrastructure, they are deploying a multi-service communication network.
So what are the requirements that this new application will impose to Prime subnetworks? I will say that there are three important requirements. First requirement has to do with security. Prime subnetworks need to implement the security mechanisms that have already been defined in Prime version 1.4. These security mechanisms will prevent intrusion, will avoid any kind of data manipulation, and will ensure data authenticity and data confidentiality. A second important requirement has to do with capacity. This capacity needs to be guaranteed. Prime MAC allows what it is called resource reservation. This is a very important requirement to assure the response times required by certain applications such as telecontrol. Finally, Prime, as any other telecommunication network, needs to be managed. It is very important to gather real-time information regarding its performance, its real-time status. In this way, we can assure that Prime subnetworks, mainly the services provided by these Prime subnetworks, will be always available.
Prime Alliance is listening to and has understood the needs of the market with regards to security requirements and is implementing them in both existing and future releases.
The emphasis on security is quite obvious nowadays, so the Technical Working Group has a specific security coordinator role that manages cybersecurity and coordinates the different task forces. Additionally, our members are progressive companies, which are accustomed to work with state-of-the-art technology. So we make sure our security provisions are following the most advanced mechanisms in terms of cybersecurity. Flexibility is also a key concept here. Different Prime users will have different security needs, so our specifications define different profiles to cover all the range. We have the option of integrating authentication and encryption features at MAC layer, along with a powerful concept of key usage and management, which guarantees data confidentiality and authenticity in real time over the power lines. The register process is a fundamental element in authenticating and configuring options for the different service nodes which need to access the network. Additionally, since PRIME is a connection-oriented protocol, it is possible to define different levels for confidentiality and authentication depending on the type of traffic. So, for example, telecontrol commands to operate the network and billing data might be using different PRIME security profiles.
With today's version of the PRIME standard, we are always considering market requirements throughout trials, pilots and deployments. We are advancing PRIME with security that has been flexibly designed so that utilities, as communication infrastructure owners, can choose among different options to deploy a secure architecture for their PRIME subnetworks.